Okay, we're going to do an energy problem. So this is going to be energy problem. Let's say we have a particle here in point A, and your particle comes and it passes through point A with initial velocity. Let's call this initial velocity, and it's going to be 5 meters per second. And then it continues and it passes through another point over here. Let's call it point B. And the final velocity when it passes through point B is going to be 10 meters per second. So your particle passes through point A with a velocity of 5, and then somehow it increases the velocity up to 10 meters per second, and that's when he passes through point B. And you know that displacement here, the displacement is going to be delta x, and the displacement is going to be 2 meters. Let's say it's 2 meters. Okay, that's your displacement. And the question is, what is the force? The force that you apply to this particle in order to go from a velocity of 10 to a velocity of, from a velocity of 5 to a velocity of 10. So this is the question. So the question is, what is the force that produces a change in velocity from 5 meters per second to 10 meters per second? That's our question. And the other question is, what is the acceleration? Because remember that acceleration is delta V over delta T. So that means that you have a final velocity minus a final velocity minus an initial velocity. So a minus an initial velocity, and you divide that by delta T. And you do have that here. You have a velocity of 5 and a velocity of 10. So there is acceleration present in this problem. So we have to find what is the force that you apply. Remember that somehow you're applying a force right here. And the force is the one responsible for the change in velocity. So how do we solve this problem? Okay, well, we can use the theorem of energy. So the work is going to be 1/2 of the mass, final velocity to the square, minus 1/2 of the mass, initial velocity to the square. But the work, I'll put it over here, the work is defined as force times distance. You can also write it down as force times displacement in the x direction, and this is a vector and this is a vector. Okay, so it's going to be the force times the distance is going to be 1/2 of the mass, and we can factorize the mass right here. It's going to be final velocity to the square minus initial velocity to the square. So it's going to be 1/2 of the mass, and let's say your mass here, let's give you a mass. The mass of this particle is going to be 120 kilograms. That's the mass of your particle right here. So it's going to be 1/2 of the mass, which is 120 kilograms. And that's going to be 10 meters to the square, and you're going to square that minus 5 meters over second to the square. Okay. So the force times the distance, and the distance is going to be 2 meters. We got that one here. That's going to be equal to 120 divided by 2 is going to give you 60 kilograms right here. And then you have 100 meters to the square over seconds to the square, because you got to square the units. 25 5 times 5 meters to the square, seconds to the square, because you got to square your units. So this is going to be 60 kilograms, and then it's going to be 75 meters to the square over seconds to the square. Okay, so the force times 2 meters is going to be equal to, if you multiply 60 times 75, you're going to get 5000. Let's go for the units. It's going to be kilograms, meters to the square over seconds to the square. Let's divide by 2 meters here, and let's divide by 2 meters here. And of course, 2 meters cancels for 2 meters, and your force is going to be equal to 4500 divided by 2 is going to give you it's going to give you 2500 kilogram. Okay, so at the top you got kilogram, meters to the square over seconds to the square, and at the bottom you got meters divided by 1. So that's going to be 22500, and you got meters seconds to the square at the bottom, because you know you got 2 fractions right here, and then you got kilogram meters to the square at the top. So this meter cancels with the square here, and you're going to get 22500 kilogram meter over second square, which is Newton. So this is going to be equal to 22500 newtons, and that would be your force. And then you got to go and get your acceleration. Well, force is equal to mass times acceleration. Oh, let me use another letter for the mass. Let me use the big M, because I'm using the little m for the units. So it's going to be the mass times the acceleration, mass, acceleration. And we got the force, so it's going to be the force divided by the mass is going to give you the acceleration. And the force is 22500 newtons divided by the mass. We got the mass. The mass is 120 kilograms. So your acceleration is going to be whatever that gives you. So it's going to be 22500 divided by 120, and that's going to throw you 187. Let's do it again. 22500 divided by 120. It's going to give you 187.5 meters over second square. And that's your acceleration. So you have your force. Your force is 22500 newtons, and your acceleration is 187.5 meters per second square. And you can deduct it. You can deduct the units over here, because you got kilogram meter over second square divided by kilogram. So kilogram cancels with kilogram, and you got your units. And there you go. You have another problem right there. You have an energy problem where you have used the theorem of energy right here. This is the energy theorem. Okay, and we'll do more problems. Thank you.